The research goal to assess feasibility of using machine learning classification models for prediction and to make recommendations if to implement in further application. The data source used, a classification dataset of the protein localization sites in gram-negative bacteria using the amino acid sequence information from the Institute of Molecular and Cellular Biology, Osaka University, Japan. The data characteristics, 7 binary and continuous features and unique sequence labels, 8 classification class outcomes, and 336 unique samples. The data preparation steps undertaken during the research. Data retrieving, accessing the data, investigating for errors, assessing for formatting modifications required, and reviewing basic statistics. No errors were identified. Data was found to be normalized, thus scaling not required. Sequence labels to be removed. Class to be converted to numeric. Data exploration, reviewing column statistics and relationships between features for the purpose of investigating the data suitability and expected behavior during modeling. Findings. The imbalanced distribution of class outcomes poses a risk to modeling performance. Bimodal distributions of continuous features identified. Clear clusters observed expected to be a good indication for modeling. Outcomes from the data preparation and exploration suggested that modelling steps to follow, train test split, model training and evaluation, would perform well from the distributions and relationships seen in the features, though would be tested on the imbalanced outcome data. The two classification models chosen for assessment were K-nearest neighbour and decision tree. Both were chosen due to their individual qualities that were expected to perform well with the dataset. The results were clear. Both failed completely on predicting the small represented classes and to reach a significantly high accuracy score. However, this was not the research requirement. The intent was to test the models to see how well they could perform, even under strained conditions. Decision tree was shown to be inconsistent across the board, thus unreliable. KNN showed consistency, robustness, and revealed the shortfalls where expected on the imbalanced data, so overall performed as expected, showing its reliability and simplicity. Next steps. The recommendation has been put forth to increase the sampling to enable prediction of all the classes. In addition, further modelling should employ imbalance techniques and/or remove the smaller samples. Research supports and recommends the implementation of KNN as the choice of model classifier to reach the outcome of using machine learning for prediction.